Good morning. Today we discuss the topic simplification of Boolean expression by Boolean algebra. When we designing a logic circuit for a given Boolean expression, for minimizing the use of components, we have to reduce the Boolean expression to the simplest form. For that purpose, that is to simplify a Boolean expression, we can choose many different methods. In that, we have to discuss two methods. First one is simplification using Boolean algebra, and the second one is simplification using Karnaugh map. When the logic equation or Boolean expression contain two or three variables or literals, we can simplify it using Boolean algebra. But if the number of variable is more, this method must be very tedious. In that case, we can use the Karnaugh map. Karnaugh map is the simplest method of solving the four variable Boolean expressions. First, we discuss the simplification of Boolean expression using the algebraic method. By Boolean algebra, we means the Boolean laws and theorems we discussed in the previous class. Now, we're going to a look at the theorems. We know that A or B is equal to B or A, and its dual form AB is equal to BA. Next, A or B or C equal to A or B or C. Its dual form A and BC equal to AB and C. Next, A and B or C equal to AB or AC. Its dual form is A or BC equal to A or B and A or C. A or 0 equal to A is dual A and 1 equal to A. A or 1 equal to 1, its dual A and 0 equal to 0. A or A equal to A, its dual A and A equal to A. A or A bar equal to 1 is dual A and A bar equal to 0. A double bar equal to A is dual is the same A double bar equal to A. It is the De Morgan's theorem. First one, A or B all bar equal to A bar and B bar is dual theorem. Or the second one, AB all bar is equal to A bar or B bar. Next, A or AB equal to A is dual. A and A or B is equal to A. It is the absorption theorem. A or A bar B is equal to A or B. Its dual. A and A bar or B is equal to AB. AB or AB bar equal to A is dual. A or B and A or B bar is equal to A. The last one, AB or A bar C or BC equal to AB or A bar C is dual. A or B and A bar or C and B or C equal to A or B and A bar or C. It is the redundancy law. Using these fundamental laws and theorems, we can reduce the Boolean expressions. The theorems given in the beginning or the first 8 are very simple and there is no need of to prove. So we start from A or AB is equal to A onwards because of we already discussed the De Morgan's theorem very well and we explain this using a truth table. Okay, so we go to the first one, that is show that A or AB is equal to A. To reduce this expression, we can express this A as A into 1 plus AB, and in the next step we take A common from the two terms, then we write A into 1 plus B, and we know that using Boolean algebra 1 or B is equal to 1. Okay, then it is a and 1, and we know that a and 1 is equal to a, then it is proved. That is a or ab is equal to a. Okay, we go to the next one. Question is, show that a and a or b is equal to a. It is the dual form of the previous one. Okay, to prove that, we must expand it. That is a and a or ab, and we know that a and a is equal to a, then we get a or ab. We know that it is the previous one. From here we can write it is equal to a using the previous theorem, or we can reduce it as a into 1 or ab. Then we know that 1 or b is equal to 1, then it is equal to a and 1, that is equal to a. Okay, then we obtain a and a or b is equal to a. The next one is, show that a or a bar b is equal to a or b. Question is, a or a bar b is equal to a or b. And here we substitute for the first term. For a, we substitute a or ab from the previous theorem. That is a or ab or a bar b, and also we substitute for the first a and a. We substitute for this a and a, then it is equal to a or ab or a bar b, and then we combining a new term, or we adding a new term, that is 0. We adding a 0 here, then we get a or a b or a bar or a bar b. These four terms can be expressed as the product of these two, that is a or a bar and a or b. From these four terms we can write it as this one, because of when we taking a from these two terms, when we taking a as common from these two terms, we can write it as a and a or b, and here also we take a bar outside, then a bar and A or B. Then we take A or B common from that terms, then we get A or A bar and A or B. Okay, and we know that A or A bar is equal to 1, then it is equal to 1 into A or B, or that is equal to A or B. Here we have some difficulty of introduce some previous result in some locations. When we make some mistake, the result must be very different. It is the demerit of this method of simplification, that is Boolean algebra. And we go to the next example, that is show that A and A or B, sorry, A and A bar or B is equal to AB. It is the dual expression of the previous one, and it is very simple to obtain. That is A and A or B, sorry, A and A bar or B is equal to A and A bar or AB. We know that A bar is equal to 0. Then the result is 0 or AB, or it is equal to AB. The next, show that AB or AB bar is equal to A. The question is AB or AB bar is equal to A. Here the LHS is AB or AB bar. We can take A as common from both terms. Then it is A and B or B bar. And we know that B or B bar is equal to 1. Then it is A and 1, and that is equal to A. The result is A. Next, its dual, that is show that A or B and A or B bar is equal to A. We multiplying both, then we get A and A, or A and B, or A and B bar, or B and B bar. Here A and A is equal to A, and B and B bar equal to 0. Then we get A or AB or AB bar. Now we take A as common from the last two terms. then we get a or a and b or b bar, and we know that b or b bar is equal to 1, then it is equal to a or a, that is a and 1 is equal to a, then we get a or a. What is a or a? That must be equal to a, then the result is a. The next is simplify y is equal to ab or a bar c or bc. You have to prove the redundancy law. We know that in the expression bc is the redundant term, then we can omit or neglect bc, the term bc, and the equation for y must be, or the Boolean expression must be, y is equal to ab or a bar c. Now we going to prove that result using the Boolean algebra. For that, we write AB or A bar C or BC. And here we multiply the last term by 1 and we replace that 1 as A or A bar. Okay, then AB or A bar C or BC and A or A bar. Now we multiplying BC with A or A bar and we write it as AB or A bar C or ABC or A bar BC. Okay, then we collect the similar terms, that is the first term and the third term combines as AB and 1 or C, and the second and fourth term as A bar C and 1 or B. And we know that 1 or C is equal to 1 and 1 or B is equal to 1. Then we get the result AB or A bar C. Okay. Now we are going to discuss more examples. Most of the questions are taken from the previous question papers of Calicut University. First one is show that A or B and A or C is equal to A or BC. We are removing the bracket by multiplying each variables that is A or AC or AB or BC. And we know that A is equal to A. Then we write A or AC or AB or BC. And here we write the first two terms as A and 1 or C or AB or BC. We know that 1 or C is equal to 1. Then A and 1 or AB or BC, A and 1 equal to A, and we write A and 1 or B. We take A from the first two terms and we know that 1 or B is equal to 1. Then we get A or BC is the result. The next question is simplify x is equal to A bar or B and A or B bar. We taking the product, we get A bar A or A bar B bar or AB or BB bar. Okay, we know that A bar A equal to 0 and B bar B or BB bar equal to 0. That is the first and last term must be 0. Then we get A bar B bar or AB. It is the result. Next question is we have to simplify y is equal to AB or A and B or C or B and B or C. We are removing the bracket by multiplication. Okay, then we get AB or AC or BB or BC. We know that BB is equal to the fourth term BB, that is equal to B, and also we know that AB or AB, that must be equal to AB. Okay, then AB or AB is replaced by only one AB, then AB or AC or B or BC. From the last two terms, we take B common, then we write the last two terms as B and 1 or C, and we know that 1 or C is equal to 1. Then we obtain AB or AC or B and 1. B and 1 is equal to B. Then AB or AC or B, taking B as common from the first and last term, we write B and A or 1 or AC, and we know that A or 1 is equal to 1. Then we get B and 1 or AC. B and 1 must be equal to B. Then it is equal to B or AC. The result is simplified as Y is equal to B or AC. The next question is, show that A or B and A bar or C is equal to AC or A bar B. By expansion, we get it as A bar or AC or A bar B or BC. Here, A bar is equal to 0. And here, look at here, AC or A bar B or BC. It is the form of redundancy law. Here, in the expression, there is three variables, A, B, and C. They repeated 2 times, and the one of them is complemented, that is A is complemented as A bar in the second term. Then we know that the other term, that not including A or A bar, must be the redundant term, that is BC is the redundant term. Then using the redundancy law, we can remove BC, or using the algebra we discussed to prove the redundancy law, we can reduce it, or we use the redundancy theorem. Here we use the redundancy theorem. Then we write AC or A bar B. Then the result is, reduced result is AC or A bar B. This question is, show that AB or A bar C equal to A or C and A bar or B. Here, from this sum of product term, we have to obtain a product of some term. In that cases, we have to add, or we have to obtain more terms. For that, here we adding the redundant term BC. Look at the expression, it is AB or A bar C. Then here there is three variables A, B and C. Here A is complemented in the second term. Then we can write or we can add a redundant term BC to here. It will not change the truth table. Okay, then we add the redundancy term BC, and to obtain that product we also add a 0 here. We are adding a 0 as a bar. Okay, then we write AB or A bar C or BC or A bar. These four terms can be arranged as A bar or AB or A bar C or BC, and we taking A outside from the first two and C outside from the last two. We write A and A bar or B, or C and A bar or B, and we take A bar or B common. Then we get it is equal to A or C and A bar or B. It is the result. Next question is, show that B bar or AB is equal to B bar or A. Here we write the first term as B bar and 1 or AB, and we substitute the 1 as 1 or A, and we expand it, that is B bar or B bar A or AB. Then combining the last two terms as taking A common, then we write B bar or A into B or B bar. B or B bar must be equal to 1. Then we get the result B bar or A. Now the last question of the today's sessions, show that AB or ABC or A bar B or A B bar C is equal to AC or B. Here we combining the second and fourth term, taking AC common from the two terms. Then we write AB or A bar B or AC and B or B bar. We know that B or B bar is equal to 1. Then we get AB or A bar B or AC, and we take B common from the first two term, and we write B or B and A or A bar or AC. and we know that A or A bar is equal to 1, then we write it is B or AC. The result is AC or B. Using this method, that is the Boolean algebra, for simplification of Boolean expression is a tedious process in the 3 variable case also, and there is another limitation also, that is when we reduce a Boolean expression, we can't say that it is the simplest one. Our aim is to simplify a Boolean expression to its simplest form, then only we can use the minimal component. So to simplify the Boolean expression to its simplest form, we must go to another methods. The next session we must discuss Karnoff map. It is a graphical method for simplification of Boolean expressions. Okay, thank you.